Today we're going to talk about emission spectras. So before we talk about emission spectras, we've got to talk about the particular subatomic particles that allow us to view emission spectras, and that would be our electron. And one model that we use a lot of times to model our electron movement is our Bohr model. So this presents the nucleus in the center, and then it's surrounded by outer energy levels or electron orbitals. So we see this blue electron here. We move to the graphic to the right. We see that when electrons absorb energy, they move away from the nucleus towards those outer energy levels. And when that happens, we say that the electron has kind of gone into this excited state. So it'll absorb some sort of light or heat energy, and that electron will move to the outer orbitals. So we see here that each of these orbitals has a number associated with them. So that would be our energy level for those particular orbitals. And we've seen this number before when we talk about electron configurations. So these particular numbers are those large numbers that we see out front of our S, P, D, and F. So the smaller that number is, that means that electron has a higher probability of being found closer to the nucleus. The higher that number is, the further away that electron is from the nucleus. So we have an electron in the excited state. When that electron emits energy, it moves from a place far from the nucleus back down towards the nucleus. It doesn't quite get to the nucleus, but it moves towards the nucleus. And as it does that, it emits energy in the form of light. Once it's back down in that lower state, that is called the ground state. So let's talk a little bit about the energy of that particular light. So the larger that transition is, say from 6 to 1, the more energetic that light is compared to maybe a transition of 6 to 5. So we can kind of determine the energy of the particular light that's emitted based on the color and wavelength of that light. So we see that violet light is more compact, it has a shorter wavelength, and we also can see that it has the highest energy or kilojoules per mole. Compared to on the further end of the spectrum, our red wavelength, which is quite stretched out, that is the lowest of the energies. So if our particular atom was emitting some violet or indigo light, we'd note that as high energy, and that was a large transition versus orange or red, which would be low energy or a shorter transition.